Use Laplace transform techniques to solve this differential equation. So we're going to apply Laplace transform to the left here, and we can break this up into three separate terms, and I can distribute the x prime to both the t and the -2, but I skipped that step here. So we'll talk about that in a second. First, let's focus on the Laplace transform of t times x double prime. That's just taking negative derivative with respect to s of s squared times x of s minus s times x of 0 minus x prime of 0. Now, t times x prime will be this one, the derivative with respect to s of s times x of s minus x of 0, and the Laplace transform of -2x prime is -2 times quantity s times x of s minus x of 0. And then finally, Laplace transform of x is just x of s. That's going to equal to 0. Now we want to take advantage of the initial condition that x of 0 is 0. So a lot of these are going to, or some of these are going to cancel, like this, this, and this. So we can simplify it to this expression. Now we have to apply the derivative. So taking the derivative of the first bunch here, whatever's in the bracket, we have to apply the product rule. So product rule for s squared times x of s. And the derivative of x prime of 0. X prime of 0 is just a constant. It's 0. So the derivative of 0 is just 0. So these first two terms is equal to that. And then we have to apply the product rule again here. So that's going to be for these two. And now I could just distribute the -2 with the s times x of s and then leave the x of s there. At this point, I can factor out the negative x prime of s. So we have x prime of s in both of these. And so we have s squared plus s factored. And then for x of s, we have -1, -2, that gives you -3. -2 gives you -5, plus one of these. Actually, this one, no, we don't need. This one has an s. So let's be careful here. So we have negative s of x of s gets canceled with this one. And then we have these two over here. So this becomes -4. And that's why I have a -4 there. Now I just multiply both sides by a negative. So now it's positive. At this point, I move the 4s times x of s to the right. I have x prime of s over x of s. So basically, divide both sides by x of s and s squared plus s. The s's are going to cancel because I can factor this as -4s over s times s plus 1. And now what's left to do is integrate. So we have ln of x of s is equal to -4 ln of s plus 1 plus a constant. Okay, so this constant, I purposely made it equal to natural log of something. And the only reason I did that is because I can absorb that constant inside the natural log using log properties. So treat this as ln of a minus 4 ln of s plus 1. So then this is what you get. So let's try to write this out. Actually, the 4 is going to come up as an exponent. And so a is going to be on the top, s plus 1 to the 4th is going to be on the bottom. And then we're going to do e to both sides. And so that's going to be x of s equals a over s plus 1 raised to the 4th power. Now we're going to apply the inverse Laplace transform to both sides. So on the left side we'll have x of t, and on the right I can factor out the a. A is a constant, so I can just factor it out. And then I'm going to multiply by 6 and 1/6. I can then factor out the 1/6, and this will turn into, well, 6 is just 3 factorial. And the reason I'm writing like this is because that's just going to be e to the negative t times t cubed. And then with the a over 6 in front, this is just a constant, so I just called it b times e to the negative t times t cubed. And this is my final answer.